Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at this question. The question says that you have a complex number omega, which is z minus 1 on z bar minus 1, where z is equal to x plus iy, and definitely z bar is a conjugate of z. Now it says that we should show that if the complex number omega is purely imaginary, that this complex number is purely imaginary, then this this is the thing. The problem is that this question is incorrect actually, because they cannot be asking us to prove that if a complex number is purely imaginary, then this happens. We need to have maybe an equation or whatsoever, and I think it was a mock question and many students have been complaining. So I've not solved the equation yet, but in this video we are going to solve it and see, like, we try to develop the proof that the examiner wanted the students to prove. That's basically what we are going to be doing. So let us begin. Our omega is equal to x plus iy, which is z minus 1, that is it, then divided by z bar minus 1. But z bar is the conjugate of z, and we know how to get the conjugate of a complex number. You just need to change the sign in front of the imaginary part, so x minus iy, then minus 1. Now I'm going to group the real parts and the imaginary parts together, and remember that x and y are both real numbers. So the real part of the numerator, I'm going to take the x with the negative 1, so that's the real part, so x minus 1, then plus iy for the imaginary part. In the denominator, I'm also going to group the real part and the imaginary parts together. So we are going to have x minus 1 minus iy. Alright, now from here we need to multiply the numerator and the denominator by the conjugate of the complex number in the denominator. So when we do that, we are going to see what we are going to have at the end. Alright, sorry, there is a little error. The denominator here is supposed to be x plus 1, so I just give you the equation. So here is supposed to be x plus 1, so here is x plus 1. Alright, so to this complex number I am going to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator simply means that I negate the sign of the imaginary part. So in place of x plus iy, it becomes in the place of negative iy, it becomes positive iy, and I'll divide by the very term so that it cancels off. But now we are not going to cancel the terms off. We are going to multiply the numerators of those separate fractions and their denominators together. Alright, now if we multiply their denominators first, let's begin. We see that you simply have the square of the real part minus the square of the whole imaginary part. So that's what we do. So we have x plus 1 all squared minus negative iy all squared, minus iy all squared. You see that this is just the difference of two squares. It's x plus iy is x plus 1 minus iy, which is this quantity here in the denominator, and then times x plus 1 plus iy. You see, now the numerator we need to multiply. We see that we multiply x minus 1 with x plus 1, it just gives you x squared minus 1. That's the difference of two squares. Next we multiply x minus 1 times iy, so you have plus iy into x minus 1. We multiply iy with x plus 1, we get iy into x plus 1, and finally we multiply iy with iy, it gives us I squared times y squared, y squared. Alright, so the denominator will be simplified. So here I'm just going to allow it as x plus 1 all squared, then here is supposed to be I squared y squared, but I squared is negative 1, it multiplies with this negative to give us positive, so we just have plus y squared. Now let us simplify the numerator by grouping the real and the imaginary parts together. So the numerator, let's simplify first. So I'm going to copy everything and then we try to simplify together each term. So the IY, right, I'm going to factor out IY from this term. I will move the IY from here, and then I replace I squared with -1. Alright, now we need to rewrite our complex number omega. So I'm going to just write the denominator. Then now let's simplify the numerator. I'm going to group the terms together. The real part, you see, the real part will be x squared minus 1 minus y squared. So we have x squared minus 1 minus y squared. Okay, now plus I into, now the imaginary part, right, you see that this -1 we add up to this one to give us 0. This x will add up with x to give us 2x. Then we need to multiply it by y, so we have 2xy. Okay, now let us separate this complex number into the real part and the imaginary part. Since the sum of the fraction of the numbers of the terms in the denominator have a common, in the numerator have a common denominator, you can just add them separately, taking into consideration their common denominator. So I'm going to take this first term here, that's a real part of the complex number, divided by the denominator, plus now 2xy, which is the imaginary part, 2xy divided by that denominator, then I multiply with I. Now we're being told that what? We're being told that our complex number is purely imaginary. If the complex number is purely imaginary, it means that this real part does not exist. In other words, the real part is 0, so we just get the imaginary part. So for it to be purely imaginary, so for our complex number to be purely imaginary, we have that the real part of our complex number should be equal to 0, so that we are going to be left only with the imaginary part. So it means that I just need to copy the real part of my complex number. So this I equate to 0. I can cross multiply, and when I cross multiply, you see I get x squared minus 1 minus y squared equal to 0. So you see that we have developed the proof. So the examiner forgot equal to 0 here, so it was supposed to be equal to 0. But now if you're a wise student, you need to develop your proof, and you do exactly, because it's a mere error. So you just need to understand what the examiner is asking. So we see that for the complex number to be real, to be purely imaginary, then x squared minus 1 minus y squared should give us 0. What about the complex number being purely real? If it is purely real, it means that the imaginary part is 0. So at the end, we are just going to be left with 2xy is equal to 0. That is x equal to 0, y equal to 0. It all depends on the initial conditions on x and y. So guys, that is that for the video. If you have difficulties in complex number, comment so that I can do a full lesson on complex numbers and upload. Make sure you subscribe to the channel and turn on your notifications so that whenever videos are uploaded, you'll be notified to come and watch. Please, there is something maybe you might not be seeing clearly, then you need to adjust your resolution, because maybe your resolution might be at 144. Your YouTube, you just need to go to your settings and you choose a higher resolution, maybe 360 or 720. All depends on you, so that you clearly see what is displayed to you.